So today we're talking about heat transfer, and there are three mechanisms by which heat energy is transferred in the atmosphere. So energy is just a fancy word for heat, right? Because heat is energy, right? Lots of energy creates heat. Okay, lots of energy creates heat. And so heat, just being a fancy word for energy, is transferred in our atmosphere by three different mechanisms. The first is conduction. All right. The first is conduction. Second is convection. And then the third is radiation. The only reason I'm not going into detail on these is because we're going to go into detail in a little bit. But there's conduction, convection, and radiation. Those are the three different types of ways that heat transfers through our atmosphere, right? And not just in our atmosphere, but throughout Earth. Okay, heat always moves from a warmer place to a cooler place. So the best thing to do is take your hand and sit it on your desk. All right, set it on your desk, and you can feel that the desktop is cold, and that's because the heat from your hand, the warmer object being your hand, the heat from your hand is moving into the table, right? Because your hand is warmer than the table, so the heat from your hand is going to move towards the table, right? The table is going to then take in that heat because the table is cold. It's got to get warmer, right? It's going to take in heat when possible. All right, so heat always moves from a warmer place to a cooler place. If you ever need to think about it, just put your hand on the table and think about what's happening. Hot objects in a room, then, right? Think about your hand, right? A hot object in a room, in a cooler room, right? Cooler room being the table, they will cool down to room temperature. So your hand is actually attempting to cool itself down to the desk temperature because they're in contact with each other, right? Your hand is cooling is warming the desk up, right? Which in turn is cooling your hand down. All right. Cold objects, on the other hand, the desk will warm to room temperature, right? Will heat up to room temperature if it's in a warm room, right? So your hand is cooling, the desk is cooling your hand down, right? And your hand is warming the desk up, right? Warm object is your hand, cold object is the table, right? So that's how it works. So heat transfer. If a cup of coffee and a popsicle were left on the table in this room, in this classroom, right, Mr. Long's science classroom, what would happen to them? And why? So you got to explain. So if a cup of coffee and a popsicle were left on the table in this room, right, in Mr. Long's classroom, what would happen to them? And why? Right? The cup of coffee is going to do what? It's going to get cold, right? It's going to get cold until it reaches room temperature. The popsicle is going to melt, and then the liquid will warm to room temperature, right? Because one is colder than room temperature, one is warmer than room temperature. They're both going to equal out until they get to room temperature. Okay? So heat transfers through molecular motions, right? Heat moves from hot to cold, right? This is conduction, right? This is conduction. So conduction is where you have two objects literally touching one another, right? So your hand touching the desk, that is conduction, right? Direct contact, right? Solid to solid, right? So conduction is when you have your hand touching the desk. That's conduction, right? And then conductivity is material's ability to transfer heat by conduction, right? Hence why conductivity, right? It comes from conduction, right? So conductivity, material's ability to transfer heat by conduction, right? So here you've got a hot metal touching a cold metal, right? And the heat is moving towards the cold, right? So eventually the hot is going to cool itself down, but the warm is going to heat up. Right? And now you get this nice, everything's the same temperature. Okay, it's the same reason why if you have a spoon and you put a metal spoon over a fire, eventually your hand's going to get burned because the heat is going to travel up that spoon until the entire spoon is hot. Okay, metals have a high conductivity, right? They transfer heat very, very, very well. They also lose heat very, very, very well, right? Same thing, likewise, pretty much anything metal, right? But then you have low conductivity stuff like carbon. Okay, carbon fiber is one of those. A lot of gases are like that. Wood would be like that. Pretty much anything that's made with anything that has high carbon in it is going to be not great at conductivity. Okay. So the next one then is convection. Okay, convection heat transfer, and that's the transfer of heat through mass movement of a substance, right? So the substance is moving to transfer that heat, right? And this substance could be a gas or a liquid. Density is present here because as things heat up, they start to expand, which make them less dense. And less dense things tend to rise, especially in liquids, right? You get a you get a really big piece of lead and you throw it in the water, it's going to sink to the bottom. All right. Then you get styrofoam, you throw it in, it's going to float. All right. And that's because styrofoam is very light, it's not very dense. Lead, on the other hand, is very dense, right? So lead's going to sink to the bottom of the water. Right. So the more dense moves down, less dense moves up. And so what you get is this cycling, like we've got here in our pot, where the cold water is more dense than the warm water. So the warm water heats up, it starts to expand, it starts to rise, and then the cold water takes its place because it's heavier, it sinks. And so you start these cycles called convection currents, which are happening in this boiling pot of water, right? So you get the cold water coming down, the hot water coming up. All right, so examples again would be boiling water, warm air, right? Today was a great example, right? Monday was a great example of convection currents, convection happening in our atmosphere, where the sun is hitting our atmosphere and heating up the air. And so as the day goes on, warmer air is moving up, being replaced by colder air, and that just continues to happen until eventually it's 70 degrees outside and it's nice and comfortable outside. All right. The last type of heat transfer is radiation. All right, and that's those red squiggly lines that you see in the picture. Okay, radiation is just radiant energy, right? It's radiant heat. It's the transfer of energy via electromagnetic waves, and it's transferred through empty space, right? There's no contact happening. There's no convection currents happening, right? This is just transfer of heat, right, through empty space. So think about when you're sitting next to a campfire, right? Most of you have been camping. So when you're sitting next to a campfire, you can sit 3 or 4 feet away from the fire because you can still feel that heat coming off the fire. That's radiation, right? That's radiant heat. That's radiant energy happening to you, right? So, the sun warming your face would be that. The apparent heat off of a fire would be that, right? That's radiant energy, that energy that's coming off of an object, right? Even you and I have radiant energy, right? That's why if you get next to somebody who just did a workout and you can kind of feel the heat off of them, right? That's radiant energy coming off of them, right? We can create radiant energy, right? Tough workouts, we can create radiant energy. It's kind of interesting. So that's what we have today for heat transfer. All right, make sure that you've gotten these notes written down. It's very important that these notes are in your notebook. All right, have a good rest of your day. All right, make sure that you're working on the assignment that I have for you.